Hello, everybody, and thank you for joining us for MCP Exposed, our webinar about MCP and the inherent risk. With me is a security expert, Denise Cruz. My name is Golan Youssef. I'm the CSO and one of the co-founders of Pint. Been doing security for more than 20 years and got to see a lot and have this perspective uh, for understanding what's coming next. Denise, would you like to
Yeah, no, thanks for inviting me. This is great. I've now deep into Gen AI stuff. I'm doing 4 startups all around open source stuff that I'm coding, and it was actually recently I did another presentation where I got to look at the MCP blast radius, and I have to say I was a bit shocked, with the state of affairs. I knew it was bad, but I didn't realize that it was so bad by design, right? And maybe it's just a caveat, right? We all here think that this is the future, like this is super exciting, and then the challenge is to do this in a more secure way. And I think we need to understand the risks so that we actually build the security in a better way, right? So this is why I think it's very important that we really cover the issues of MCP security.
Yeah, couldn't agree more. And maybe before we continue on discussing, maybe let's have a quick recap about MCPs. So MCP is like a system, a protocol that allow for connection between different elements. We have the host, which is the application itself. We have the MCP client, which is the smart agent, like the Gen AI or the LLM agent that powers the system. And we got the MCP servers that provides like tools, capabilities, interactions, and with the real world interaction with data, with API, stuff like that. Actually allowing the MCP to act on the environment and to get information from the environment, give us much richer functionality than just chatbot.
Yeah, in my presentation, one of the concepts I arrived, which I think is quite interesting, is I think the MCP protocol is what the Swagger guys and the open, API would have developed if they have seen this amazing presentation by Brett Victor a while back, where he talks about how it would be great if in the future the APIs could interact and more dynamically. And they
Mhm.
kind of, started with the premise is, what if the server API was dynamic fluid, right, and not hard coded? Well, if the clients could communicate with it, right, and load the schema dynamically and all that stuff, right? And then what if the server could communicate back to the client, who talks to it, right? And even if the API could change dynamically its own spec, right, halfway through it. In a way, they are very good business requirements, but
Mhm.
every one of them has ridiculous security implications, right? And I think that's the challenge. I think the challenge is we have the next generation of basically Swagger, right? The next generation of how APIs can interact with, but we kind of left security sort of a bit in the back of the bus, right? And I think we need to bring it a bit more front and center. How I think a lot of people are starting to realize.
Yeah, exactly. It's crazy. Just 1 year ago, Dennis, you and I had like a webinar talking about the LLMs and
Yeah,
the risk they have, like the inherent risk. And now we get this risk like multiple, like now they with real impact, with real danger to the that can be caused by an attack or by mistake even. And so yeah, as you said, this is crazy. It's capable and it's moving fast and it's without like solving the issues that that are inherent to the system.
yeah. But let's be clear, like MCP solves a real hard problem, right? Like which was happening, which is how can an LLM communicate with other? How can you make sure the schemas updates and in a way, now that we have the power of consuming, specs dynamically and deciding where to route the traffic, it's a really important protocol. And with the Gen AI revolution, you now have basically pressure from the top and almost the bottom at the same time, right? So there's lots of projects, but I also think that the reason why a lot of projects are starting to fail or not really delivering in the real world is because they're realizing that although it works on specific use cases, the corner cases can be and the exploits can be so dramatic that the
Hmm.
risk is ridiculously high. And that's probably why we're seeing all these sort of 20, 30, 50, 70% failure rates of pushing into production. Because I think when it really hits the real world, if this thing is not properly protected, right, it won't go live.
Totally agree with you. I have a question to the audience. Like, how many of you started implemented MCPs? Have you tried using it? Have you tried using it with your products, maybe with your offering? Please answer in comments. And as you said, Dennis, you're working with clients that try to implement it, and you see these difficulties, right? That's what you started saying.
Yeah, look, I tend to also basically a lot. I think everybody that tells me they need an agent, I basically said you don't, right? You want workflows, right? The last thing you want is independent freaking entities in the middle of your business logic, right? And so my approach is a lot more about trying to control the blast radius and trying to control the paths that you go through, right? Because that allows us to almost like start from the premise that you're gonna get prompt injection, you're gonna the data's gonna be exfiltrated if you're not careful, right? And then it's about the more you understand the APIs, the more you understand what the APIs are actually doing, and MCP is just an API, right? It's just another ridiculously charged endpoint, right? It's like an API that has SQL injection by design, right? It's almost SQL execution, remote code execution by design, right? And you can't separate code and data. Apart from that, right, we're all good, right? So that's what I think, that it's important to understand the blast radius, important to understand the paths, and one of the things you guys really did in this research, which I thought was really freaking cool, was you looked at the compound effect, right, of multiple MCPs, and I remember looking at that going, yeah, this is a really interesting concept, because in APIs, usually the assets and the dangers and the risk is addictive, like this plus that plus that plus this, or maybe there's an intersection. But I think, like the stuff you guys talk about here, is that when you have more MCPs, I actually think that you have a multiplication effect of the risk, right? Because at the end of the day, like if even on this example, right, and you can go in more details, like if you look on the right, every one of those MCPs there that you put on a solution, right? And for the reference, this idea here is that you have a solution that has multiple protocols, right? Using multiple servers. Each one of those can potentially compromise the whole thing. Each one of those, the schema definition, the responses that he gets can potentially, jeopardize the whole integrity and of the thing, of the whole solution.
Totally agree. And we have like a lot of opportunities for attackers to come into the system. As the more MCP servers that you have, the more interaction with the real world that you have. And on the other end, we also have the more capabilities, right? More
Yeah,
stuff that successful attack can achieve.
yeah. And one of the things that when I start looking at these compound effects, because this is the thing that's so easy to do, right? It's so easy to add a lot of more MCPs, because in a way each one does one thing useful, right? Oh, this one goes to the internet, and that one checks your emails, and that one goes to the calendar, and that one accesses this file system, and that one accesses this internal thing, and this one does that. Is I was looking at the tool choose, right? And this is interesting because the more MCPs you have, the more dangerous and interesting becomes the first step of the workflow, or the steps of the workflow, which is how do you choose the MCPs, right? And even then, you can have injection, right? Even on that first step, which is which MCPs do I'm going to send my payload, you can already have injection, and you can have all sorts of name collisions.
Yep. And it's there. The name collision happens all the time, and you can see the confusion in real time of which tool to use. There is no like a way for you, or like a clear way for you to indicate to the system that you prefer using one tool over the other, right? As a user.
Yeah, so that means that if the first box there was, for example, read email, right, and send email, you could have an MCP later on that also registers send email to contact, for example. In fact, you could even be a little bit more specific, and that means that when the agent, or the workflow on the host, right, is trying to figure out which to call, it might actually call that more specific MCP endpoint, like send email to contact, instead of the original Gmail official send email, right? And that means that you can then be, not knowing if you actually are sending data to somebody else.
Yeah, it's interesting. I didn't think about it till now, but maybe we'll have like MCP optimization, like we have SEO optimization,
Yeah,
the optimization, like have dedicated description or good enough description so your tool will get priority over other tools that competing with you on the user actually.
And that's one of the problems with MCP. The A2A, the Asian to Asian framework on that, I think the Google's right, or the Microsoft pushed. It's a little bit better, right? They thought a little bit more about that, and I think the MCP needs a couple of extensions on how to actually start to have authoritative sources, right? And almost like it's almost like not every MCP should be the same, right? Not every MCP should be able to overwrite the other one. Especially, you shouldn't be able to get a freaking prompt injection from an MCP description. Right.
Exactly, and that's so easy for an attacker to do. Like if you control the MCP server, then the MCP client would just listen to you. It will do whatever you tell it to. And you don't even have to sweat. It just do that. It will do that.
And
And
this is the thing I would say to visualize that I think sometimes a lot of teams and don't fully visualize this was that the prompt that goes to the LLM contains everything, right? So there's
mhm,
a moment in time where you have a prompt that is going to an LLM that has data that you got from the MCP definition, that has data that you got from each of these MCP's answers, and it's all in one freaking prompt, right? So every one of those places that you get data from the MCP server, either the description, the task, what you did in the end, the answers, etc. Every one of them is a prompt injection possibility.
exactly. And all you need to do, all attacker need is one chance to have a prompt
Yeah.
injection. So what if you have a MCP server that pull content from untrusted source, and then you have other MCP server or maybe even the same MCP server that can do stuff interesting from the perspective of the attacker,
Yeah.
uh, then then you have a vulnerable system, right? And
Yeah.
and the, and we show that the more you have in this research, we actually show that the more system you have, the greater the risk is. The chances that you have a vulnerable system is higher, and the impact, the blast radius that you talk about, is
Yeah.
exponentially bigger.
Yeah.
In
So Rick just asked a cool question here, or comment says it says MCP optimization for whom, right? Isn't that an attack vector where the MCP optimization to be selected by server request? So Rick, the bottom line is a ridiculous attack vector, right? And at the moment, the way it works is when an LLM that is powered by MCPs receives a request, the first task that it needs to do is to choose which MCP calls to make, right? And the problem here is that you now have an interesting engineering problem, which is if you include every definition from every MCP in your prompt, in that original prompt, technically you are being more authentic and you have less chances of hallucinations or going to the wrong place. But that also grows exponential because it means that the bigger the tool definition, the bigger that prompt goes. So what actually happens, and this is when I was reading about, like, alarm bells go in my head. It's like you already have an optimization done in that first step. And some people do with RAG databases, which again is crazy dangerous because you're basically almost saying, what is the approximation of all my API tools that I have for this query using a vector database? But because vector databases are approximations, by design, if you have official and unofficial endpoints, they're going to arrive in the same list of sending over, right? So in a weird way, one of the first major Achilles heels of this whole solution is that process of selecting the tool to, not even the tool to send, is the tools to send to the LLM to choose the tool to send. And that's why this idea of compounding risk is even more important, because it means that the more MCP servers you have, the more critical is to choose that curated list to then choose what MCP call to make.
yeah, yeah, absolutely the case. But this is like the case where the MCP server itself is like rogue, or being turned over, being hijacked in some way, right? But there are also the cases that nothing in the system is bad for itself, right? We have MCP servers that don't have vulnerabilities. We have a MCP client that we trust, but we still have like huge attack vector just because of the composition of
Yeah.
those the composition of those different parts. Uh,
Mhm.
one interesting thing I saw just now was like a security researcher found a vulnerability in Corsa, and they reported it to them, and they just say, "Hey, we know about it. You just never should use MCP servers that can access untrusted content. This is something that is not solvable. And this is how like there is no real solution for it from their perspective right now. It's,
Yeah.
they
Oh,
knew.
and that's the problem. Like we still don't have a good solution for prompt injection, right?
Mhm.
So and it's it's a bit rich to say, hey, don't allow untrusted content to arrive at MCP. Where like, dude, untrusted content is freaking everywhere, right? That
Exactly.
could be a web page, that could be an email, that could be a DNS entry, that could be the MCP tool definition.
Exactly.
So it's about like when you say, hey, don't click on bad links, and you go like, dude, the internet works by clicking on, right? Like, so don't click on links. What? So how do I use the internet, right?
Yeah.
So it's way up there with that security guidance, right?
Yeah, it's and also if you're referring to links and the web, for me it's like the state we are in right now is very similar to the way the web was back in the days, like in the 90s. Right? Very vulnerable, a lot of vulnerabilities everywhere. You can say you can find
Yeah,
and easy to exploit also. And very easy to find, very easy to
yeah.
exploit. And this is the same, but only the impact here is much more serious, I think.
Yeah, because now it's like it's plugged in, right? Like, I remember doing this security review where we were looking for SQL injection, and then we found a method called SQL execute, right? Like literally, because at the time where you want the clients to be able to do stuff on the server, write
Yeah.
some queries, right? But then he was running out of system, right? And it was like game over, right? So we learned to protect our APIs because even with exploit and security and threat modeling and good security practices, and now we just went backward 10 steps, right?
Yeah.
Because the APIs now can think for themselves, right? They're not well protected. They're running over privileged identities. We can't separate code and data. It's like fucking hell. It's like what can go wrong, right?
Yeah. No real solution. Nothing.
Yeah. So walk us through this example because you guys you did some really cool research, right? And you found some really good exploits, right? So it's good to show for real like what actually was happening here, right?
Yeah, we actually did experiment with the Cloud Desktop. We hooked it up with two MCP servers. Both are like totally legit, no issue with them. One was the Google Gmail server, and the other was some server able to execute code. And then I worked with the Cloud actually directly and asked it to test itself, see if it can be full, and he referred to itself as the new instance of itself, like the new me, and tried to hack it. And they actually created emails, and each time I send those emails and they ask Claude to read the email and do whatever, and reported back to the hacking Claude what the result were, and he analyzed it and tweaked the email. We did some back and forth for it until it managed to achieve like a code execution, meaning the code use use the MCP server to read the email, and then without asking for permission, executed another MCP tools and another MCP server that was able to execute code. So even the hard part here, like the prompt injection, you don't have to sweat. You can just ask an agent to do that for you. That's that's not real no real hurdles here. You got everything laid out for you.
Yeah. So just to be clear, right? So you're actually using Claude to hack itself, right? To
Yeah,
then say what is the best prompt that I can use to hack
yeah,
myself, and then
yeah,
eventually you got it to work, right, with the prompt injection on the MCP,
exactly,
right?
exactly. It created the prompt injection. Like that's what
Yeah.
the work for. And each time, like refining it, analyzing, seeing what went wrong, thinking about new method to try to fool itself. It was
Yeah.
it was nice. It was funny, and but also serious, because it shows that both our LLM can be used as an attack aid, like helping you with the boring stuff or the harder stuff in the attack, and how they are vulnerable and how it can be exploited. So we got the two risks here
Yeah.
demonstrated.
Yeah, but you also found a lot of really cool examples of like that chain, right? Like, when you have multiple MCPs and one of them becomes compromised, and then you start to use that one to use the capabilities of the other MCPs to
Yeah,
basically exploit the whole chain, right?
yeah. This is the new research. The new research actually explain how the chaining of the MCP how work, because we can assume that once you have a way for attack to get into the system, an attack prompt to get into the system, then it can compromise the system, and then from there, it's easy for it to like use a set of tools, use one tool to trigger another tool, use a chain effect. Um, a lot of possibilities here for an attacker. Also, the ability to ask the agent itself for questions. So the MCP server can have a way in the protocol to send queries to the LLM agent. And so with that, you give the attacker like the power of smart agent sitting on your device or on your environment and
Yep.
asking you like it's a full blown confused deputy with all the power that you gave with its
Yeah, and look, and I think that's the key message here, right? Like now you got this compound effect, right, of connecting multiple LLM agents, and going a bit to the stuff that you guys do at Pint, right? I feel that the fundamental challenge here is our core infrastructure is not fit for purpose, right? Like we don't have an infrastructure that allows us to easily understand how do all the moving parts work, how do the web services and the APIs actually behave, right? But
Mhm.
also, I think one of the key fundamentals is the fact that we don't log everything, but we also don't have like. By the way, if you want to get one advice from me on all this stuff, is log everything. Like log every single post data that you get from the client that you send to the server, because we kind of mentioned in passing is that the actual MCP servers can change their own definitions
Mhm.
in the middle of the freaking workflows, in the middle of working together, right? With which basically means that if you're not careful, you might not even have logs to understand which and who got called, right, or
Mhm.
why they got called. Because when you look at the definitions, like a week later, or a day later, or an hour later, your actual server already has different definitions, right? It's like, but so I think logging is super critical. But one of the things that I really feel that we need to really start doubling down is the whole identity access management, and we need to understand much better the exact privileges to do
Mhm.
so. One of the only sane ways that I can see today to mitigate the risks of MCPs and these solutions, because they're going to go live, is to have very, very sort of almost like cookie cutter permission set for each of the servers and each of the activities, especially the hosts, but also ideally do even per request. So the logic here is that the more granular the identity access management tokens, the MCP servers and the hosts are running, the more you can control going off piste, right?
Couldn't
And
agree more. It's like we really need the granular permission model with temporary permissions, like having one time token, and that's truly so. But
yeah, but
also
yeah. And
also
so just finish on that one, and that's why we need to solve the problem of understanding and documentation and threat modeling and visualization of our services and our
Mhm.
workflows, right? And this is where I think we can use Gen AI to do this, because the new generation of Gen AI tools, right, they now have a much bigger ability to understand what is actually going on, right? So if you think about it, the more we understand the flows and the more we understand what the code is actually doing, and the more we can document it, the more we can. It's a chained effect, right? Because
Mhm.
the more you know about each part, the more you start to be able to understand the compound of each of those components, right? And that's what the way I look at API security is all about that, right? It's about understanding that, but then not don't just point vulnerabilities that are obvious. Also start saying, hey, here are the privileges that you need to execute this particular function. And if the privileges you need to give it massive permissions, then hey, that's a vulnerability in itself, right?
Yeah. Um, yeah, and so like testing your models, testing your setup to understand what's going on, what the risks that you're facing, have like understanding of what's going on, and then you can come up with a mitigation plan or containment plan, something like that. I think this is really important at this phase. That's what we were talking about it, calling as the shift left moment.
Yeah.
One last question to the audience is what what uh, what are your concern about using when deploying using MCP, and how do you handle it if you do? Let us know. It's really interesting for us. Um,
So the other thing that I feel that I would like to see more from the tools, since I can ask for stuff these days, right? Um, is I think we need to understand better the blast radius, because, for example, when you say, "Hey, can you access my calendar?" Right, that sounds benign enough, right? What we should say is, "Do you want to give access to this tool to make sorry, uh, damage that cannot be repaired, irreparable, right? Damage to your calendar, right?
yeah,
Like these days, our calendars don't have integrity, right? If somebody, if even if by accident an agent adds 5,000 or 10,000 entries to your calendar, it gets destroyed, right? Most people's calendar is probably one of their biggest assets, right? And
yeah,
that's mine. Like I go for my calendar, right? So the I think it's very important to start saying this is not just giving right access to your calendar. This is like giving you access to a calendar to with permissions that can technically destroy it, and not more that you can use it to attack something else. You give
mhm,
access to a repo, that means that you can rewrite history, right? People, I think there's not this wide understanding that unless you sign every single Git commit, I can create a commit in Gulen's name, right? And it will look just like that. I can create a pull request that has literally anybody I want in there saying good blah 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 and putting commits, right? Because if you have write access to a repo, you can do all that stuff. So I
mhm,
think part of this sort of again shifting left and understanding the blast radius is we need to be a lot more clear on what the permissions can actually do, right?
yeah,
And especially because most of our databases, most of our systems don't have integrity, don't have versioning, don't have journaling, which basically means that when either maliciously or unintentionally, right, you can do ridiculous amount of damage, and some of them cannot be repaired.
that's absolutely true. And so having like a permission set, something it's not, as you said, not available. We need some way to control the action. Maybe we should treat things differently if it's been done directly upon a user request or been done through other channels, other flows. Maybe the flow themselves should be like determine the.
Yeah.
Uh, um, so yeah, yeah, please, Dennis.
Yeah, no, I think we're wrapping up, right? And
Yeah,
this is actually a really cool research, right? I definitely recommend you guys to take a look at it, right? Because I think it's especially the compound thing. This really made me think of like, yeah, this is actually worse than I thought it would be, right?
it is. It's just like it's open door. That's why it is open doors. So to wrap up, because we are out of time, Dennis, I'll invite the audience to connect to us on LinkedIn to continue the discussion, or if you have any question. Feel free to download our full study. You got the QR code here, and the last QR on the right side is for if you want first taste of Pine solution for the MCPs. So drop us a request, and we'll be glad to include you. Denise, as always, it was a pleasure talking to you, having a chat with you, having a host something with you.
Yeah.
And
And but just to say, like have a positive note, right? Like this is really good stuff, right? Like now, the more we understand these risks, the more we can find solutions. So we've been here before, right? We know how to fix a lot of stuff, right? So, for the guys attacking this, keep doing it. For the defender, this is a great opportunity to focus on this, right? So I think this is all positive, evolutions of our industry.
absolutely, absolutely, we are here for the development. We don't say to people don't do that. Just be aware, go with it, improve it.
Yeah, just a bit radioactive. Just be careful with it. Brilliant. Thanks for the invitation. It's always fun to talk about these things.
Great, Denise. Thank you very much. Thank you, everyone. It was great.